Hi everyone. Welcome to the first lesson of high school geometry. And in this lesson, we're going to take a look at points, lines, and planes. I'm Teacher Bob, and today we're going to explore the basic geometry or geometric elements that form the foundation of geometry. I promise to make this as fun and engaging as possible, so let's get started. Okay, so let's dive into points, lines, and planes. These are the building blocks of geometry. Understanding these concepts is crucial to mastering the more complex topics later. First, let's talk about points. A point represents a location in space and really has no size or shape or dimension. It's usually represented by a dot, and we can call this point A if we like. You can just illustrate the point with an A in this case, or with any capital letter, like a point A or B or C or whatever is necessary for the illustration. Next we have lines, and a line is really just a straight one-dimensional figure, and it extends infinitely in both directions. It's made up of an infinite number of points, and it's usually labeled with 2 points on the line, like A, B, if you like. That can be lowercase, so we could draw this like this, a line with an arrow on each end, and we can put 2 dots here, and we can call this line AB, or between the 2 dots would be line segment AB, but a line, infinite number of points extending on into infinity. Okay, and next we have planes. And a plane is just, it's flat, it's two-dimensional, it extends infinitely in all directions. It's many times represented as a parallelogram. Looks like a sort of a rectangle, and this to represent like a flat tabletop, if you will, and it's just extending in all directions into infinity. Sometimes the plane can be labeled as a capital letter like plane M, or it can be labeled by 3 non-collinear points, like you could call it plane ABC. Collinear really means 3 points or points on the same line. If they're not collinear, that means they're not on the same line, and we'll talk about this more. Okay, so let's look at an example. Suppose we have, let's say we had points A, B, and C, and A is at 0.12 and B at 3.4 and C is at 5.6. And we want to determine if these lines are collinear, meaning are they on the same line? So let's just write this up here for reference. So A, point A, it's just a capital letter. The location of point A is at 1, 2. We put this in parentheses afterwards to show the location of the point. And B, we said is at 3, 4. And C is at 5, 6. Okay, 3 points. Question is, are they collinear? Well, what we can do, we want to determine if they're on the same line. Well, what we need to do is we to check if they're collinear, we need to use the slope formula between any points, and we can do that. Slope, well, let's take one step backwards in case you haven't heard the term slope for a while. A slope of a line. We're talking about between any of these 2 points here in our 3 points here that we're trying to determine if they're collinear, is or can be defined as rise over run. And the rise can be shown by the difference in the y coordinates. We call that delta y, divided by the run, or the difference in the x coordinates between 2 points. So that triangle, it's given the name delta, and it just means change. So the change in the y's divided by the change in the x's. Now if you have 2 coordinates, we can also write this in a formula. M means slope is equal to the difference in the y's, so that would be y2 minus y1 divided by x2 subtract x1. So we can calculate, for example, well, let's take a look at A and B. If we made a line between this point and this point, A is coordinate 1, 2, and B is coordinate 3, 4. And we use this formula here. We can write this into the formula. The slope of line segment AB, we can write it out like this, is equal to, we've already written up the formula here, so that's 4 subtract 2 over 3 subtract 1. That gives us 2 over 2. So we have a slope of 1 for line segment AB. Okay, what about BC? Well, let's calculate that. So the slope of line segment BC is equal to, let's subtract our y's and subtract our x's. So we've got 6 subtract 4 for our delta y, and 5 subtract 3 for our delta x, or our rise and our run. And look, again we get 2 over 2, which is equal to 1. These slopes are the same. Okay, so that's not too hard. Since the slopes are equal, A, B, and C are collinear. Okay, let's move on to another concept. Now let's talk about intersecting lines and planes. When 2 lines intersect, they meet at a point, and when a line intersects a plane, they also meet at a point. When 2 planes intersect, what happens is they meet along a line. So we can show this in an illustration. 2 lines, they intersect at a point, a plane and a line. They're going to also meet at a point, and it could look like this. So we could have a line. That's the area, or what's intersecting between 2 planes. Line of intersection could be over here, could be over here, but the point is the 2 planes where they intersect is a line. Okay, so let's solve a problem involving the intersecting lines. Suppose we have a line L and a line M, and they intersect at point P, and line 1, let's say, passes through points P at 23 and Q at 4, 7, and line M passes through points 2, 3, and 6, 1. The question is, are they perpendicular? Perpendicular means that lines touch each other or go through each other with an angle of 90 degrees between them. We often show this in our illustrations with a box. Now we can determine this, whether 2 two lines are perpendicular by figuring out what the slope is, and then we take the product of the two slopes, and they're -1, they are perpendicular. So let's take a look at the points on these lines here that we know of. So we want to figure out the slope of line L, and we're given the point 7 and 3 for the y's and 4 and 2's for the x's. So let's just subtract on our y's and subtract our x's, and what do we end up with? A slope of 4 over 2, so our slope is 2. Slope of line M, and we were given the y's and the x's, plug them in. We're just using the slope formula here, by the way, which is y2 minus y1 divided by x2 minus x1 to calculate the slope. So we're doing this for these two lines. So we end up with, for line M, 11 subtract 3 divided by 6 subtract 2. We get 8 over 4. So we get 2 again for our slopes. So is 2 times 2 equal to -1? No, it's equal to 4. So 4 is not equal to -1. So then we know that the lines are not perpendicular. Okay, now it's your turn. What I want you to do is look at these 4 questions that I've put on the screen, and I want you to read through them. I want you to practice these, pause the video, and try and solve them on your own. And then resume the video and come back, and we'll talk about these questions and we'll work through the problems together. Okay, so take a look at these questions now and try them on your own. Okay, welcome back. Let's take a look at the first question on the board. Number 1, determine if points D located at 1, 1, E at 2, 2, and F at 3, 3, coordinates 3, 3, are collinear. So the question is, are they on the same line? If they're on the same line, then they're going to have the same slope. So what between 2 points? So let's do a couple of these. I'm just going to go to the next page, number 1. Okay, so if you've got that written down, let's take a look at, we're going to use, first of all, the slope formula. M is equal to y2 minus y1 over x1. And if we want to figure out, let's check the slope between points D and E. So M, or the slope of line segment DE, we show a line segment as with a little line over top of it. And let's put in our x's and y's, and we get 2 subtract 1 over 2 subtract 1. That gives us 1 over 1, which is equal to a slope of 1. Okay, let's try another one. Let's try EF. So the slope of line segment EF is equal to, well, that's y2 minus y1 over x2 minus x1. Plug in the y's and the x's. We get 3 minus 2 over 3 minus 2. We're getting the same slope here. We get 1 over 1, which is equal to 1. Again, we've got a slope of 1. If we do that again with line segment DF, which is the only other combination of 2 points creating a line, we're going to get the same slope. So yeah, they're collinear. Okay, question 2. Find the slope of the line passing through the points, and we're given 2 points, G and H, with their coordinates 2, 5, and 6, 9. Okay, so it says find the slope. Well, that's easy. We've been doing that already lots of times. So where the slope is equal to y2 minus y1 over x2 minus x1, rise over run, delta y over delta x, and that's equal to 9 minus 5 divided by 6 minus 2. So what is that? That's 4 over, oh, what's my math here? 6 subtract 2 is 4, so that's, what is that? That's 4 over 4. It's equal to 1 over 1. Okay, we get a slope of 1 for our question 2. Okay, number 3, determine if lines passing through points I, J, and K and L are parallel. Okay, well, if they're parallel, they're going to have also the same slope. So that's all we need to do. So we just figure out those two lines. If they have the same slope between those two lines, then they could be parallel. Okay, I'm going to leave that, and we're going to go on to 4 because that's nothing new. And number 4, we were being asked, find the intersection point of lines y is equal to 2x plus 1 and y is equal to negative x plus 4. So we have two linear equations here. If you remember back a couple or 3 years ago, we were looking at linear equations, and they took on the form of y is equal to mx plus b. B being the y-intercept, and m, of course, we recognize from today's lesson as the slope, and y and x are just any 2 points, any point on a line, and we know that we've got an infinite number of points on a line. So what we've got, two lines. We've got y is equal to 2x plus 1. So got any y and any x that go together as a point on the line. We've got a slope of 2, and the y-intercept is 1. And the other line is y is equal to negative x plus 4. Okay, so if you have no coefficient, that's the number in front of a variable, you just assume that it's 1. And in this case, it's a negative 1. So that means we have a slope of negative 1 for the second line. And for the first line, we have a slope of positive 2. If you have a positive slope, your line goes up to the right. If you have a negative slope, your line goes down to the right. And these last b numbers here, or variables, just tell you where on the y-axis the line crosses. Two lines, at least two linear equations here, give you what's called a system. And if you're asked to solve the system, what you're being asked to do is to find out, is there anything in common between those two lines? Is there an x and a y coordinate that is true to both of these lines? So when you've got a system, you can have one of 3 different situations. You can have two lines that cross each other, and what's common to both lines? Well, this one point right there, and that's going to be represented by an x and y coordinate. So if you're solving for a system and you get 1 point, you know you've got two lines crossing. If you've got no points, but you've got the same slope, you know that you've got two lines that are parallel to each other. And if you end up with the same slope and all y's and x's, or x's and y coordinates, work for each of the lines, then you've got two overlapping lines. You've got one line on top of the other. Generally, quite often, you're going to get this situation here. Okay, so let's take a look at this. We're going to use what's called substitution. This is one of two methods of solving a system of linear equations. So substitution, what we're going to do is we're going to find out what one variable is and then plug that variable back in and find out what the other is. For example, we can figure out what y is or what x is, and once we know what that is, we can plug that back into one of these equations to figure out the other variable. Well, this is a fairly easy one. We know that the system is y is equal to and y is equal to, two lines where y is equal to. So what does that tell us? That tells us that these two expressions here are equal because this is equal to y and so is this. So we can rewrite this as 2x plus 1 is equal to negative x plus 4. And we go back to grade 5 or 6 math and we can just simply isolate those x's by doing the opposite operations with each of the terms. So I'm going to put my x's on the left side, my numbers on the right. So how do we get rid of this positive 1? We add a negative 1. What we do to one side of the equation, we have to do to the other. So I'm going to, these two cancel out. I want to get rid of this negative x on the right side, so I'm going to add. If we were multiplying and dividing, well, the opposite of multiplying is dividing, and the opposite of dividing is multiplying. So that's what we do, what we would have done. Okay, so these two cancel out. We're going to add an x to the left side. Pardon me. So we end up with 3 x's on the left side and 3 on the right side. Divide 3x by 3. Have to do that to the other side. We end up with x is equal to 1. Okay, so in our answer, we're looking for one location, maybe. We know that x is 1 anyways. So let's put 1 in the coordinate here. Okay, so if we know x is 1, we can use one of these equations over here in the system. Let's just use the top one. Y is equal to 2x. Oops. Pen working here again. Okay, my pen has quit working on me here. Okay, well this is pretty easy to see, and we're at the end of, oh, there we go, my pen working again. Okay, so y is, we're going to use 2x okay, my pen is still not working. Okay, well you can see here that y is equal to 2x plus 1. We know that x is equal to 1, so we'll just plug 1 back in to where the x is. 2 times 1 is 2, plus 1 is 3, so our coordinate is 1, 3. Those two lines cross each other or intersect at coordinate 1, 3. Okay, so there you have it. That's the end of our lesson today. And you just had to imagine there. I'll try. Well, let me know if you don't. Give me a text or an email if that part you didn't quite get. This week, and I'll get back to you to explain it. I'll send you a little video or something. Okay, great job, everyone. Remember, understanding the basics of points, lines, and planes is essential to mastering more complex geometric concepts. Keep practicing, and if you're still struggling, you'll master these concepts in no time. Take a look at the worksheet, practice those, see that your answers match the answer key. If you're still not comfortable with some of this, get in touch with me through the week. Tell me specifically what your issue is so I know how to best help you. And remember, this is a journey, and I'm with you every step of the way. Okay, have a fantastic week, and we'll see you in the next lesson. Bye for now.